So, for the purposes of the meeting, I just want to notify us that the meeting is being recorded and we are going to be proceeding. If you have any friends or someone you would like to invite for today's event, please feel free to send them the link to the meeting. So, my name is Clinton Mbonu. If you don't know me, I am the CEO and founder of Lightbulb AI Labs Limited, where we are building AI powered workflow systems for tertiary institutions and personalized learning for students. Today is the third, the third or the fourth, I think it should be the third um, lesson or session in our many part series called Making Sense of AI. And the first section, we talked about patterns and data. The second session, we talked about prediction. And today, we are going to be talking about rule-based systems. Normally, our meetings happened on Saturdays, but because tomorrow is Valentine, and I know that many of you would be going out to or be enjoying your time with your loved ones, I decided to see your beautiful faces today to say happy Valentine and run this through as quickly as possible. We wouldn't be taking a lot of time in today's meeting. We are going to be talking about a topic that has been since as far back as possible regarding the concept of computing, and that is rule-based systems. Everywhere you go, you hear machine learning, machine learning, machine learning, machine learning. We are going to get to that. But before machine learning, before adaptive learning, there was rule-based systems. So we are going to be talking about rule-based systems, how he has been applied over time till date, and what is how to recognize rule-based systems and how we move from rule-based systems to adaptive learning, machine learning systems. But before we start, I showed you guys something on the screen before now, and it is time for you to tell me what animal is the animal that has hair, it has claws, it has sharp teeth, it has forward pointing eyes, it has, can you see the screen now? I am showing that to you. Let me share my screen again. All right, so the animal has hair, it has claws, it has sharp teeth, it has forward pointing eyes. The animal eats meat and it has dark spots and it is very fast. What animal do you think this is? I already gave you a clue. It is an animal. So who will be the first person to tell me in the chat box which animal is this? Does anybody know? Okay. Bianca said cheetah. Does anybody have any contrary opinion to this? Any contrary opinion? Chinemerem, are you on the line? Do you have any animal you think this could be? Kamsi Yochuku, do you have any animal you think this could be? Bianca may be wrong. Okay, Kamsi said same. Chinemerem, what do you think? Bianca said, oh, my neighbor. Okay, I think our the animal is cheetah. So Bianca, you have just won yourself data worth of 5,000 naira for joining our meeting today. Some of you may wonder, why did I start by asking these questions? This question. Today's topic is about rule-based systems, and if Bianca was a computer tool, she saw a couple of rules that she used to identify that the animal is cheetah. So the hair, the claws, the sharp teeth, the forward pointing eyes, the meat that the animal eats, which means the animal is a carnivore. It has dark spots and it is very fast. Set of rules that helped churn out a particular outcome. That is the foundation of deterministic logic systems. Before we had neural networks, before we had prediction models, or even systems that learn from data, the world ran strictly on logic. If it is this, then this. So it was a time of intelligence without reasoning, some kind of reasoning. Imagine all those times you filled a form and immediately you apply for a job, and before you finish for the day, you just get rejected immediately. It's not that the system wasn't thinking, it's that the system was following a specific instruction. The people that put out the job search or the job opportunity for you to join on had created a set of rules that the system follows to churn out candidates. So before the current hype of AI that you are hearing, the invisible layer that kept everything and governed and even still govern most of our digital interactions is actually rule-based systems. It's not about memory, it's not about learning capabilities, it's not about strip everything you've heard about AI and focus on pure logic that is being executed. So the singular atomic unit of this logic is if condition, then action. If a computer is shown a picture of cheetah, if hair, if carnivorous, if dotted spots, if can run fast, if pointy eyes, then picture equals cheetah. Or for some of us that are students, if attendance is less than a certain amount percentage, deny exam access. So these rule-based systems make decisions using predefined logic. So if they ask you what is the layer, the atomic layer of logic in computing, it is conditions and actions. For example, ATM withdrawals. You've been using a rule-based AI system whenever you walk into an ATM machine. At a time that we didn't have POS in Nigeria, you would easily just go to an ATM machine stand and then put in your card, and it checks what is your balance. Have you exceeded your limit? Then withdraw. University eligibility prerequisites. What is your cutoff mark before you can be able to write for a certain university? Do you have maths before you can do computer science? Do you have mathematics in your WIAC before you can do computer science? If not, change of department. And so on and so forth. Security, password strength, and the rest of them. Even loan approvals. You can think of so many things, so many systems you have interacted with that followed strict rules that when there are edge cases needs its rules to be updated to a certain place to accommodate those edge cases. So the systems grow based on the number of rules it has in its database or in its knowledge base. So in every case, the logic follows the same path. If X, do Y. Finish. If paid, fee, show result. If balance greater than amount looking to withdraw, the person, the user is looking to withdraw, else say insufficient fund. We interact with these deterministic agents on a daily basis without even often realizing it. You go to the market, you finish buying, you say, Madam, POS, you just put your card. Madam, you dey collect transfer, what's your account number? These are agents that run based on rules, and they leverage the if X, do Y logic. So what is inside most of these machines? For example, the first thing you would have is the rule book, the working memory, and an inference engine that it uses to churn out decisions. The rule book can be a set of cases, use cases. It does not try to use probability to determine what is best for you. That is what machine learning does. But rule-based systems, you define all the rules that it's supposed to operate on. And then the working memory are the current facts and context. Current facts and context include the scenarios that it has passed, the scenarios that it has used these rules on. And then the inference engine, where it processes everything based on whatever input you have at the given time to now give you the decision. So the inference engine acts as the bridge, deciding which rule from the knowledge base applies to the current facts in the working memory. So what are you looking for right now? Which rules match with this current facts, whatever the user wants at the point? How do I adjust my decision? How much do you want to withdraw? Based on our rules, did Money Point say that this particular credit card has bonus? Or did the owner of this credit card block the card? Is the status of this card still active? Because those are the current facts. If the status of the card is no longer active, then it would make a decision not to let you withdraw. What we did just now is called forward chaining. I gave you a bunch of facts and you were able to determine the animal. When I told you, oh, what is the animal that has hair, has claws, has this, has that, you were able to tell me it's a cheetah. But what if I just said, is this a cheetah? That is backward chaining. I have taken you to a goal. Most of these systems, either they use forward chaining for reasoning or backward chaining for reasoning. And even as humans, we do the same. So I didn't give you facts. I just asked you to confirm. And for you to validate this goal, what would you do? You start asking, does he have hair? Does he have fur? You might not want to wait to ask whether it eats meat. Because once you've seen the claws, you've seen the hair, you've seen everything, you would determine that this thing, the way you look at the pointy eyes. So what animal has this, and is this a cheetah? One takes you through forward chaining, the other one takes you through backward chaining. For many of us in computing, you would understand it even better. However, we are touching some of these terminologies for everyone so that as we grow and evolve as a society, you will not be left out on the basics and the foundations of most of these tools that you are using every day. Because the more you understand them, the more you will be able to leverage them for your day-to-day life and even build on top of them, because we are in the creator economy. So an example of forward chaining here is attendance is 60%. It checks the rules, then it denies you. Backward chaining, can the student sit for the exam? Then it will start checking. So this mechanical process is often the first introduction to automated reasoning in computer science. This is the base of reasoning, automated computing. That computer is reasoning. Computers can think like human beings. It's either doing forward chaining or backward chaining. That's why many of us then in school, one of the first things they will tell you to build is an ATM machine, which would work like magic. Now we've been spoiled as a people. We've seen more complex technologies. But if somebody told you when a ATM machine came out newly that you could walk into a humanless bank and be able to withdraw money, you will scream. That was the bedrock of AI in banking at the time. So we have moved from this set of rules to a time of black box AI. Rule-based systems offer auditability, offer you the ability to review the playbook for which AI is using to operate. But right now, with the systems that we have in place, it's some sort of a black box because it hallucinates and it does not have the ability to you cannot predict at a given point what it is going to do next. That is why we have black box in AI. Every big tech giant says AI is some sort of black box because you don't understand how it makes its decisions based on probability. However, where you have control of is the data that is being fed into the AI. But with rule-based systems, you enjoy transparency, you enjoy predictability, you enjoy compliance-ready systems, and even efficiency because it doesn't process a lot. When we get into machine learning, you will see the high why we have stems like compute power. But with rule-based systems, rules are already defined. So there is no the computation cost is easier to manage and better and faster rather. Not faster though, but more affordable. But rules explode in complex environments because they cannot handle nuances. For example, in my company today, one of the challenges we've been trying to fix with our technological solution has been a case where the rule states that if you are to switch from a department to another department, you should not make any payments so that the payments of the previous department that you found yourself will not be allocated for you, so you don't carry it into your new department. But because there are human interference and a tertiary institution is a complex environment where there are so many moving parts, so many rules changing in real time, people can actually make their payments and say, oh, jam delayed my change of form later, now I need to change my department. Imagine 15-20 people doing that so close to an examination period. We create what we call the brittleness of rigidity. The systems begins to glitch, things begin to go, issues start arising, people start noticing behaviors that are not supposed to be. The system breaks or acts unjustly. People will start feeling like they are being witch hunted because it cannot nuancely interpret context, and it lacks the ability to learn or scale effectively. That is why my company decided that we are going to be infusing artificial intelligence in workflow systems for tertiary institutions. Because why most of these systems do not scale is because of the rules that keep changing very rapidly. So as we build and scale our solution, we are leasing machine learning capabilities for the system to adapt based on the ever-changing rules. For example, ATM machines used to be for withdrawing cash. At some point, we needed ATM machines that will take cash as well. What happens? They need to build an entirely different machine that can also receive cash. So the systems learns logic from data, but machine learning is pattern discovery by the machine. For rule-based systems, it learns logic from the data you give it. But machine learning learns patterns from the data. Once it sees how many times a certain thing has happened or occurred, the most probable fact becomes its go-to resolve. But with machine learning, with rule-based systems, it follows logic from the data, from the rules you've put. If income is greater than 150K, approve the loan. The human writes the logic, rules are the instruction that you give the machine. So anytime it sees this logic, it is going to behave like that. But with machine learning, if it sees that you wrote if income greater than 150, or let's talk about let's use a lab results based machine learning system that tries to interpret the lab results and lab tests of what's it called, of patients for them. A typical lab result comes with a lot of variables and numbers. A rule-based system can be programmed that once you see typhilia plus the person has typhoid. A machine learning system can see patterns. Everybody is coming with this certain amount of certain values on the different variables that make up their anatomy. Maybe it's not typhoid. Maybe typhoid is not the actual problem. Maybe it is stress. Maybe it is the atmosphere. Maybe it's the weather. Once it understands the pattern, it can make better predictions. But for rule-based systems, whatever you have told it, is typhoid, is typhoid, is typhoid. So life today, in the modern architecture of technology, we are relying on both layers. We create rule-based systems that are layered on machine learning, or machine learning systems that are layered on rule-based systems. And the rule layer plays a role of safety, compliance, and the rest of them. That's why your Instagram can block you out if you post certain kind of post contents, because there are rules specified. But AI is there. You on Instagram, you rarely see the posts your friends make, but you can see those things that you are interested in from different people you are not even following, because AI is already controlling what you see. You are no longer seeing what you want to see. You are seeing what AI predicts to be what you need to see. And for most of the time, it is something you actually want to see until you decide to reset your FYP. But the rules that run there are rules that don't allow you see certain kind of things, generate certain kind of things with AI. The rule layer provides security. So from this in edtech, the rule layer blocks exam access if fees are strictly unpaid, which means for our software, tertiary institutions can actually decide that if you've not paid a single installment of any of your fees, at least you are supposed to not write the exam. And once that rule is set, it is set. But AI layer can actually predict student dropout risk based on the behavioral patterns. So instead of blocking out everybody without actually paying attention whether this person wants to drop out or not, it can block you and still generate a report that this set of people are at the risk of dropping out. So modern architecture rarely relies on just one approach. It uses the stack. So after studying all of this, I start thinking, are humans essentially rule-based machines? Because what we call intuition is often deep-seated pattern memory, a biological version of logic we program into machines. If traffic looks heavy, leave early. If lecturer repeats a point, study that pattern. If fuel price rises, adjust your spending or look for NMPC to buy. Maybe they may be cheaper. That was then, but not now. Everything we build in artificial intelligence is mirroring us as humans. So the more you understand the AI, the more you understand yourself. The more you understand the logic and the thinking behind creation of AI, the more you start referring it more as collective intelligence and artificial intelligence, because it is externalized consciousness, the data of everybody's thought process, answering the question for everybody. Here is your strategic advantage. The future belongs to those who understand the architectural difference. So when you hear that UN is calling for regulation, China is calling for AI regulation, Nigeria should start talking about regulating its own AI patterns and having its own AI rules. This is us calling for structured intelligence layered on top of this adaptive black box intelligence. Because true strategic power lies in knowing when to demand structure and when to allow for adaptation. So when you hear rule-based systems, they are structured intelligence. When you hear machine learning, they are adaptive intelligence. Why is it adaptive? Because it keeps evolving beyond the rules that guard it. And that will be all for today. I don't know if we have any questions for what we have discussed today. Does anybody have any questions? If you have any questions, please put it in the chat. Yes, today was meant specifically to be short so that people can go back to whatever they need to do and prepare for their weekend. Today we've talked about rule-based systems and machine learning, how rule-based systems are structured intelligence while machine learning is adaptive intelligence. Both of them are used in our day-to-day lives. Right now, you cannot tell ChatGPT to do certain things for you because there are rules. There are a set of rules that are layered on top of it to make sure that while we are allowing it adapt to solve your problem every day, it is not going far away from those guardrails that make it ensure that we are following the collective practices that make us human. If not, it can generate certain things that may be destructive to whoever is using it. So that will be all for today. Thank you so much to everybody for joining. It's been an interesting one. Personally, I had fun talking about rule-based systems because over the past couple of this the entire week, my company has been working hard to adjust our solutions to with the rules that have been changing with tertiary institutions that use our services. And that has shown me how it is how important what we are building is, because the better your system is able to adapt to ever-changing rules, the better the service you provide to students, academic stakeholders, and everybody that use your service. My name is Clinton Mbonu. If you are just joining us, I am the CEO and founder of Lightbulb AI Labs Limited. We are building AI-powered workflow systems for tertiary institutions and personalized learning for students. Today, we spoke about rule-based systems and the role it plays in artificial intelligence. And I want to use this opportunity to say a big thank you to everybody. Enjoy the rest of your evening. Happy Valentine, and God bless you. Bye.